Hi, Bindu. Bindu, are you here?
Yes, ma'am.
Okay, and Chiranjeev, are you here? Chiranjeev, can we wait 3 or 4 minutes more so that people can join us? Okay,
Okay,
Bindu.
ma'am.
Okay, sure. Thank you.
Yes, ma'am, I am present.
Okay, Chiranjeev. Shall we start, Bindu?
Yes, ma'am.
Yes, ma'am.
Okay, so I think you people are new to this live session. So let me introduce myself. My name is Jyoti Sharma, and I will be the teaching assistant of Dr. Ankur Avadia for this course, Conservation Geography. So I will try to summarize whatever he taught you in this week. And in addition to it, I will try to solve the questions whatever has been given in the assignment, but yes, I will not tell you the exact answer to it, right? Bindu, can you please introduce yourself? Like, what's your background and why did you join this course?
Ma'am, I'm Dr. Bindu KB, working as assistant professor in Department of Geography, Kannur University. And I feel it very interesting to learn new aspects. That's why I always attend courses in UGC Swayam platform. And this is my third course. That's why. And the topic, conservation geography, it was very attracting. That's why I joined. Thank you, ma'am.
Okay. Okay, actually, I'm just a PhD student, so I think I should call you the ma'am. So, Bindu ma'am, please help me while I'm getting some problem while solving the questions. Okay, so I hope you will help me out while I face some difficulty while answering the questions to the students. So, thank you so much, Bindu ma'am. Uh, Chiranjeev, can you please introduce yourself?
Yes, ma'am.
Chiranjeev?
Ma'am, myself
Yes.
Chiranjeev Dekha. Yes, ma'am. I'm pursuing MA degree from Banaras Hindu University, and I joined this course due to in my syllabus, SWAYAM course is necessary for a master's degree.
Okay, so you are MA Hindi student.
MA geography student. Ma'am.
Okay, okay, you are also just geography student. I think three girls also joined from BHU. I don't know the name. One is Momita, yes, and
No,
second
ma'am.
I don't know. But
Many students joined. More than 80 students joined this course.
okay, okay, okay. Thank you so much, Chiranjeev.
Okay, okay.
Shubham Kumar, can you please introduce yourself?
मैम मेरा नाम शुभम कुमार है। मैं बनारस
Mm-hmm.
हिंदू यूनिवर्सिटी से एमए की डिग्री ले रहा हूँ। मैं मास्टर ऑफ ज्योग्राफी है। मैं
Okay, so
ये
you all
मेरे
people
सिलेबस
are
का
from
पार्ट है, इसलिए मैं
geography.
ज्वाइन किया हूँ।
Okay, okay. So you all are from geographic background, but let me please tell you that I have that environmental science background. So it may be that sometime I don't know the answer of the question you ask from me. So please help me out whenever I find difficulty. Okay. So thank you, Shubham. Naveen Kumar Jain, please can you introduce yourself?
Yes, ma'am. Namaste, ma'am. I'm Naveen Kumar Jain. I'm pursuing MA from Banaras Hindu University, and this is part of our course, so I joined it.
Okay, okay. Thank you, Naveen Kumajan. I already know Khushbu that she is from BHU and she is doing the MA Geography. Am I right, Khushbu?
Yes, ma'am. Good evening, ma'am.
Okay. Good evening. So let's start. Let me share my slide. So is it visible to all?
Yes, ma'am.
Bindu? Okay, okay. So I already have introduced myself. I'm Jyoti Sharma, and I will try to summarize whatever Dr. Ankur Avadia taught you in the week third. Okay, so let's start with the fourth sphere of the Earth. Okay, so we have like Earth is a whole. And we can say it is a system. So Earth is a system where we have divided four part of the Earth. The first is lithosphere, the second is hydrosphere, the third is atmosphere, and fourth is biosphere. And it is not that they are very separate identity. No, this is not, because whatever the energy is going within the lithosphere, it moves to the atmosphere, it moves to the hydrosphere. So I think you know about the biogeochemical cycles. So the energy flow within all the sphere of the Earth, and the when we talk about this four sphere together, then we will call it is the Earth system, right? So this has been we will talk about the Earth sphere. So first first subdivided part is lithosphere. So here we will talk about the solid earth, and this solid earth may be formed of the rocks, the solid part such as the sand and the soil. So such part of the earth sphere is known as the lithosphere. If there is a gas that surrounds the earth, then we will call it the atmosphere. If there is a water, then we will call it the hydrosphere. And when this lithosphere, atmosphere, and hydrosphere work together, so it forms the biosphere where the living organisms can survive. Okay. So, because this week is dedicated to the lithosphere, so we will talk about the lithosphere more. Whenever you have any query, you can raise your hand and ask the question. Whenever I'm wrong as well, you can correct me and you can raise the hand as well. Okay. Okay. So let's talk about the composition of the lithosphere. So what's the composition of the lithosphere? The definition says a lithosphere made up of rocks and solid elements. So the important part is rock. We will know, we will talk about the rocks, what are the rocks, what they are composed of, and what are different type of rocks in the next slide. Okay, so the important terminology is rock. The second important terminology is the solid elements. So these solid elements can be the soil, can be the sand, but we will study it in the next week. So the most important part here today only in the live session will be the rocks. Okay, so let's talk about rock. What's the definition of this? The definition says a rock is an aggregate of one or more minerals. Okay, so here we have a new terminology that rocks are composed of the minerals. We should know what is the minerals, right? So, and the second important point about the rock is that they do not form the definite composition of mineral constituents. So let me explain it more. Suppose we have a granite. So granite is a rock and it is composed of quartz, feldspar, and mica. Okay, so suppose the quartz, we have quartz in this granite, the 80%. Okay, feldspar, we may have like 5% composition of this granite is feldspar. Okay, and then the remaining part is mica. So there is a no definite composition of mineral constituent. It can be like quartz can be 50%, feldspar can be 20%, and the remaining can be the mica, or some other minerals can become other minerals can be added to form the rocks. Okay, so we have two property of rocks. The first is rock is composed of minerals. We will talk about minerals more in the next slide. The second thing is they don't have the definite composition of mineral constituent. Okay, so in the sphere we are focusing on the lithosphere. In the lithosphere we focused on the rocks and we got to know that rocks are made up of minerals. So let's talk about what the minerals are. Okay, so what is a mineral? Mineral is a naturally occurring inorganic solid with a defined crystal structure and chemical composition. Okay, so here there are 4 or 5 different terminology. The first, it occurs in nature. No doubt, we are in the laboratory as well, we are creating the minerals, but as per the definitions, this mineral occur in nature. Okay. The second is the nature of the mineral is inorganic. It is not the organic or some other kind. It is inorganic in nature. Okay. The third is it is the solid, not liquid, not the gas. So the phase of the mineral will be solid only. Okay, then it has a chemical formula. Rock don't have the chemical formula because I told no ki granite maybe composed of like different type of minerals, and the composition is not defined. But here the composition is very much defined. That's why the mineral has a chemical formula. For example, here is the gypsum, and the chemical formula is CaSO4.2H2O. So here we can say that in the gypsum there is one calcium, one sulfur, and then we have this 2 plus 4, 6 oxygen atom and 4 hydrogen atom. Okay, so here we have definite composition. The quartz will not have like magnesium. It will have always the calcium here, the sulfate here. So it has a chemical formula that is very specific in nature. The most important part, it has a crystal structure. So what is this crystal structure? So let's see this structure. So if there is a one atom that is attached to the another atom, the bond is being shared between the atoms, and it form a crystal like structure. Okay, so each mineral may have different type of crystal structure. Like one may be cubic, one may be octahedral, one may be the 8 edges structure, one may be 5 edges structure. So each mineral have a specific crystal structure as well. And how this crystal are formed? We have the atomic structure, and this atomic structure in a very ordered way grow into the crystal. So I think the definition of mineral is very much clear to you people. Before, and because we want to know like what are the different minerals and what are the important minerals that are important to us, like that are making the most part of the crust. So we want to know that type of mineral as well. So before that we have to study something more about the minerals, because there is a silicate compound. This is very much integral part of the minerals. So let's talk about first what is silicate and about their different type of structures. So if I talk about nesosilicates, so what happens? There is a silica at the center, silica atom, and 4 oxygen atom are being bonded with this silica atom. Okay, and this is the independent, like this is not bonded with another type of such structure. It is independent in nature. That's why this is the nesosilicate or independent or the single silicate. Okay, if we talk about the sorosilicate, then this is the one silicate structure. This is a different silicate structure, and here one oxygen atom is being shared by these 2 silicates. So whenever this happens, this will form the sorosilicate. And here we have only 2 silicates, 2 silicate that are bonded, and the oxygen is being shared. Okay, when this kind of structure forms the cyclic form, okay, so this will form the cyclosilicate. Okay, and the one of the important is inosilicates. What happens in the inosilicates? When can you see the 1 and 2? 2 of the oxygen is being shared among the silicates. Okay, and this form the chain like structure. So this will form the inosilicate. Most of our crust minerals have this inosilicate structure. And then when this 2 chain structure are being again bonded with another oxygen atom, and it is a double chain structure. So this double chain structure will be the this is also the inosilicate, but this is the double chain structure. Okay, if 3 oxygen are being shared among the silicates, then this will be the phyllosilicate, and this will create the sheet structure. Okay, so this will be the phyllosilicate. And if each of the oxygen atom are being shared by another silicate, then this will create the tactosilicate, and this will also create a 3D structure or the frame structure. So the most important structure among these silicates from our point of view are inosilicate and this tactosilicate, right? Okay, so now we want to know, like, what are 6 major rock forming mineral groups? Okay, so what are these what are these 6 major rock forming mineral groups are? The first is olivine, the second is quartz, the third is feldspar, fourth is mica, fifth is pyroxene, and sixth is amphibole. Okay, so we will talk about some characteristics of these all minerals. So let's talk about this olivine. Olivine are magnesium iron silicate. Can you see the structure of this? Iron, magnesium, and then this silicate. Okay, so I think this is clear to all of you that olivine has a magnesium iron silicate component, and this is the primary component of earth upper mantle. Okay, so and the next is quartz. This is white or colorless hard mineral, virtually insoluble in water. So this is the characteristics of the quartz. Okay, the third is feldspar. The color of feldspar is light cream to salmon pink, and this is tactosilicate mineral. So I already talked about you tactosilicate. This is the tactosilicate that will form the 3D structure and the frame structure. So this is light green to salmon pink color mineral, and the tactosilicate mineral forming half of the earth crust. The next is mica, sheet silicate mineral with pearly vitreous luster. I think one of the assignment has been asked among these characteristics of the minerals. Okay, so I hope you will solve that assignment questions according to whatever we are summarizing right now. The fifth is pyroxene. This is green or black colored inosilicate. This is inosilicate. So what was a inosilicate? This is the chain structure where 2 oxygen atoms are being shared. So the green or black colored inosilicate forming 10% earth crust. Okay, so this is the pyroxene. And the last is amphibole. This is green or black colored. This is also the inosilicate mineral forming prism or needle like structure, for example asbestos. Okay, here is the formula. You can also see the different type of silicate structure and what different type of metals are being here in the formula. Okay, if we have some rocks and then in the rocks we have given different type of minerals, and we want to identify like which one is the which mineral, so how we will identify it? Okay, so there are some characteristics of mineral based on which we can guess the kind of the mineral we have in our hand. Okay, so what are different characteristics of the mineral? The first is external crystal form. I already told, like, this is the cubic structure. So it may be that mineral have different type of like crystal structure. So it may be octahedral, it may be hexagonal, it may be prismatic. So after seeing the external crystal form of the mineral, we can guess like this can be this mineral, this can be this mineral. So there may be some guesses, but yes, we can't exact tell like what is what mineral. Okay, so the second characteristic is cleavage. The tendency to break in certain direction, maintaining a crystal structure, because each mineral have some crystal structure and they want to maintain that structure. So if they want to maintain this crystal structure, whenever we cut it with knife or something else, it will cut only in a certain direction or in a certain angle or in a certain plane. Okay, so this is the cleavage. Okay, the third is fracture. If it is not cleavage, then it may be broken down in any different point. Okay, so this is the fracture, and there may be like the after fracture there may be different kind of structure we can get. It can be earthy, the cloggy. We may have different shape after the fracture. After that we can guess about the composition, about the nature of the minerals. Okay, the fourth is color. Color is like, after seeing the mineral color we can guess like this can be this mineral. But here this color may be due to the molecular structure. If it is due to the molecular structure, then we our guess is almost right. But if this color is due to some impurities, then our guess may be wrong, because this is due to the impurities. And that's why the color identity is not that much reliable. For that we use the streak. What is streak? Streak is the color of ground powder. If we have mineral, we will ground it, we will convert this mineral into a powdery form, and we will see the color of that powder. And this is the streak. This is more reliable characteristics of the mineral, based on which we can identify the mineral. The next is transparency. We will see how much light is being crossed by the minerals. Like either it is 90% light is crossing, either it is 20% light is crossing. It may be that the mineral inhibit the crossing of light. So based on that as well, we can identify the minerals. Okay, so next is the structure. It may be fine grained, it may be medium grained, it may be coarse grained. So this is also the one important characteristic. The other is hardness. So hardness is its resistance to being scratched. If there is a one mineral, so how other things can scratch this mineral? Is it possible that this mineral is being scratched by the other minerals? So if it is being scratched by another minerals, so then we can say this is not that much hard. And if it is like, if it is resisting itself to being scratched, then we can say yes, it is very hard minerals. Okay, we will talk about this in the next slide as well. And the last one is specific gravity. This is the density of the mineral with respect to the density of the water. So if the mineral has a high specific gravity, then we can also say that the atom is very much compacted, like very much tight in a lattice or in the structure here. So we can also guess something about the mineral from these characteristics. Let's talk about the Mohs scale of hardness. So one of the softest mineral is talc. The second, this is the increasing hardness from above to the below. So the softest one is talc and the hardest one is diamond. So for example, if we have talc, this can be scratched by all these minerals. That's why it is the softest one. And if we talk about the diamond, then diamond can't be scratched by all these type of minerals. That's why it is the hardest one. Okay, so the first is talc. The second number hardness is like gypsum. Like this is the increasing hardness. So I hope you people are understanding it. At the third level, there is the calcite. At the fourth, there is the fluorite. At the fifth, it is apatite. So in the sixth, it is feldspar. At the seventh, it is quartz. At the eighth, it is topaz. At the ninth, it is conundrum. And at the 10th, it is diamond. So I think, and why this hardness matter to us? Because based on that, we can tell that whether the erosional agent or the geomorphic agent such as running water or wind will erode this type of rock. This is the mineral, but based on this mineral we can guess, like, because due to this geomorphic agents and due to the hardness, which of the rock can be eroded first and which can be eroded at the last. So we can identify based on the hardness. Okay, so we initially started with the sphere, then with the lithosphere. In the lithosphere, we talked about the rocks. In the rocks, we talked about the minerals. Okay, so mineral part has been finished. Now we will come back to the rock again and we will talk about the different type of rocks. Okay, so there are three different type of rocks we have categorized. The one is igneous, the second is sedimentary, and third is metamorphic. Okay, so let's talk about igneous first. So what is igneous? These rocks are formed by heating and cooling of magma. So this is very much connected to the magma. Whenever magma is coming out or out on the surface, or either it is inside the surface itself, but the heating and cooling of magma is creating the igneous rock. Okay, the second is sedimentary rock. So we have the fragments of old rock. So suppose we have the igneous rock, it has been eroded, it has been converted into some small fragments, and these small fragments will deposit, and the after deposition it will create the sedimentary rock after some processes and mechanisms. Okay, the last is metamorphic rock. These are formed by the transformation of existing rock. So what kind of transformation? Like we have temperature, we have temperature, we have pressure. So after this temperature and pressure of a certain level, the rocks can be transformed into different type of rocks that are the metamorphic rock. I think you people are understanding what I'm telling. So Khushbu, are you here? Are you understanding whatever I'm just summarizing?
Yes, ma'am.
Okay,
I
Momita,
understand.
is that okay? Thank you, Khushbu. Momita, everything is clear.
Yes, ma'am.
Chiranjeev, everything is cleared from my side. Okay, okay. And Bindu, ma'am.
Yes, ma'am.
Okay, thank you, ma'am. Okay, so this is the summary of a different type of rocks. Let's talk more about the igneous rock. So the basic summary of the igneous rock is we have magma, and then cooling is happening, then this magma is converting into the igneous rock, and we can classify igneous rock based on three things: based on texture, based on geological settling, and based on the mineralogical composition. So if we talk about based on the texture, then some igneous rock may be the coarse grained, some may be the fine grained. So when this will be the coarse grained and fine grained, this is based on the geological settling. Okay, so if there is a magma chamber and conduit is carrying the magma, it may be like there may be two ways the magma can go anywhere. It may go on the surface itself, and it may be here here beneath the surface. If this magma cool inside the surface itself, then because there are so much gases within this magma, and if these gases are not being transferred to the atmosphere or somewhere else, okay, so heat is not being transferred, heat is under this surface only. If there are so much heat inside this, then the cooling time will be thousands of years, right? So if the cooling is taking place in thousands of years, then this rock, the mineral of this rock, will have the enough time to make the crystal structure and to grow in a to grow and to form a coarse grained structure, right? So so in the so this is because this is inside the surface, we call is the intrusive igneous rock. The second type is if magma comes out and cools on the surface, and because heat is being transferred in the atmosphere in no time, and if there is not that much heat with this magma, then the cooling will take place within seconds to months. And because cooling time is very short, then the crystal structure will not form, and this will result into the fine grained structure. And this is because this is cools on the surface, that why it is extrusive igneous rock. So if we classify based on the structure, it can be fine grained or the coarse grained. And if we classify it into the geological settling, then we can classify into extrusive igneous rock and the intrusive igneous rock, right? And third, if we classify it based on the mineralogical composition, so what is the composition of the minerals? If in the if it is a silica rich mineral and then the rock, then we will call it the felsic. So we will call it the felsic. Felsic is made up of fel means feldspar and sic means silica. So this is silica rich mineral. And if it's silica rich minerals and that's why the rock is silica rich, then this is the felsic. And the example is rhyolite and granite. If silica is more, but not as much as in the felsic, so it is the intermediate, and the example of it, dacite or granodiorite. Okay, if there is a less silica in the rock, then we will call it is the mafic, and the example of this, andesite and diorite. And if there is a least silica in the rock and the minimal quartz in the rock, then this is ultramafic, and example is basalt and gabbro. We have to keep in mind, if there is a rich silica in the rock, then this will create a light colored rock. And if there is a less silica, then this will create the dark colored rock. We can also see in the picture as well. So the classification based on texture, geological settling, and the mineralogical composition, I think this is clear from my point of view of, and also from your point of view. This is okay. So we already have talked about the igneous rock. Now, here the second type is sedimentary rock. So what are the sedimentary rock? How these are formed? So I already discussed that we have some rocks that has been degraded, that has been broken down into very small rock particle, or the sediment. We will call it sediment. So it has been eroded, it has been degraded into small sediment, and this, when this sediment will be deposited, then a layer will be formed, and after this layer a cementation will be happen, and this way the sedimentary rock is formed. So here is the structure. In the first, we can see here eroded segments are settling down in the water. Okay, they are settling down after the erosion. After the erosion, there has been sediments with us, and after the transportation, this sediment has been settled down in the water. The second step is deposition. After one layer, the second layer will be formed. Like deposition is being happening with time. After some year, a new layer will be formed. After some year, a new sedimentary layer will be formed. So this is kind of deposition. The third is this layer will reduce the moisture. This layer will reduce the water so that they can compact. So this is the compaction. So the release of moisture from the sedimentary layers make the layers compact. And the fourth part is cementation. In the cementation, we have some salt crystals that help these layers to glue together, and this will form more compact sedimentary rock. So this is the graphical way from where we can study how this sedimentary rock are formed. So we also have classification of sedimentary rock based on the mode of formation. So how these sedimentary rocks are being formed. So in this, we know that erosion has been taken place, that then transportation, and in the erosion that some rock has been degraded into the smaller part. So this is kind of clastic sedimentary rocks. Okay, so the example of this is breccia, the conglomerate, sandstone, shell, and these are formed from the mechanical withering debris from pre-existing rock. This is the same like we have rocks, then the weathering is taking place. One of the weathering is the erosion. So after erosion, we have the small rocks or the small sediments, and these sediments will deposit. Okay, so the step of formation of clastic sedimentary rocks are decay and disintegration. Okay, the second is the sediment will transport to the water or to some other place, then it will deposit, and then diagnosis, the process of transformation of sediment into cohesive, hard and massive rock because of compactions, consolidation and cementation. So this is the process in which the three things happen: compaction, consolidation and cementation. So this is the this is the clastic sedimentary rock. The another are chemical sedimentary rock. The example of this, gypsum, anhydrite and some limestone, and these are formed when some dissolved material precipitate from the solution. So this is the second type, the chemical sedimentary rock. And third is organic, when from the accumulation of plant or animal debris we get the sedimentary rock. So here the example of this organic sedimentary rock. Once upon a time we had a huge forest. After some time this vegetation dies and it formed the peat. Then peat is being compressed between sediment layer and it will form the lignite, and further compression will transform this lignite to bituminous and subbituminous coal, and after that, after much more compression, then eventually the anthracite coal will form. So this is the like coal is being formed by the organic way, because a forest is a organic in nature, right? So this is kind of organic sedimentary rocks. So in the rocks we already have talked about the igneous and then the sedimentary rocks. Okay, one of the assignment question has been asked from this as well, the sedimentary rock classification based on the composition. So what's the composition of the sedimentary rock? So here is another classification. If it is siliciclastic means the sedimentary rock will be dominated by the silicate mineral, and example of this are sandstone and mud rocks. If the rocks are being dominated by the carbonate mineral, then we will call it carbonates, and example is limestone and dolomite. If they are formed by the evaporation, no, I think this has been wrong. If they are dominating by the organic, so we will call it organic, and in the evaporation we call it the evaporate. There has been some mistake, so please pardon. So when the mineral formed by the evaporation, so we call it evaporates, and the example of this halite, gypsum and anhydrite. Okay, so and if the sedimentary rock is entirely composed of silica, then we will call it siliceous. The example of this, chert and opal. And if there is more than 50% iron in the sedimentary rock, then we will call it iron-rich sedimentary rock, and example is ironstone. And if there is a more than 6.5% phosphorus in the sedimentary rock, then we will call this sedimentary rock a phosphatic, and examples are phosphatic nodules and phosphatic mud rocks. Now the third type is metamorphic. So how these metamorphic rocks are being formed? So we have igneous rock, we have sedimentary rock. After heat and pressure, these rocks will convert into the metamorphic rock. Okay, so there is some kind of transformation due to the heat and pressure. So these igneous and sedimentary rocks can be converted into the metamorphic rocks. So here is the rock cycle. What rock cycle says that one type of rock can be converted into a different type of rock, but there are certain mechanisms, there are certain processes which has to be gone through before converting one rock to different rock. So for example, if we are converting igneous rock to sedimentary rock, then there should be erosion, then transportation, deposition, and diagenesis, as we already have discussed. Then if this sedimentary rock is being converted into the metamorphic rock, then the pressure and temperature is required to transform it. Okay, and also from the igneous to metamorphic, pressure and temperature is required. This metamorphic rock can also convert it into the igneous rock. If the metamorphic rock is melting and it is being converted into magma, and then crystallization is taking place, then this sedimentary rock will also convert into the igneous. Okay, and this metamorphic, after melting, can convert into magma, and this magma can again form the igneous rock. So this is the rock cycle, which says that any type of rock can be converted into any different type of rock, but there will be different mechanism for it. Okay, so we already have talked about the rocks, the minerals, the lithosphere. Okay, and because we are talking about the lithosphere itself, so there are different type of landforms on the lithosphere. So we will talk about the different type of landforms on the on this crust, and what are the driving factor that are forming the kind of landforms we have right now. Okay, so these kind of studies come under geomorphology. So what is geomorphology? Geo is earth, morpho is the form, logy is the study. So the study of earth's landform is the geomorphology, and we will talk about the processes. What are the processes by which earth different landforms can be created on the earth. Okay, so first let's talk about the forces. What are different forces? So we have two forces. The one is endogenic, the second is exogenic. This endogenic forces is also known as the internal forces. Because why this is internal forces? Because this force originate inside the earth. Okay, and such kind of forces forms the landforms. Okay, so the creation of landforms is being mostly happen by these endogenic forces. If we talk about the exogenic forces, then we call it also the external forces, because these forces originate on the surface of the earth, and these are the land bearing forces. Why this land bearing? Because these are the forces that are destructing the landforms. That's why these are land bearing. It is not that exogenic forces can't will also destruct the landform. This is not always the case. It may help in the land forming process as well, but mostly it will create the land wearing, means the destruction of landforms will be happen with this kind of forces, exogenic forces. Okay, and based on these forces, we have two processes. These processes are also endogenous process and exogenous process. So what is endogenous process? The processes that are caused by forces from within the earth. Okay, and exogenous processes that come from the forces on or above the earth surface. So based on these forces, we have two processes, that is endogenous and exogenous. So here is also some difference. When there is the endogenic process, this will originate in the interior, and this will create the sudden or the rapid movement. We will talk about it in the next slide, how this causes the sudden or the rapid movement of some landforms. Okay. Then we have exogenic processes. This cause the slow movement. And example here is the earthquake, faulting, diastrophes, and here the example of erosional and depositional. We will talk about it at length in next slide. Okay. So here is the geomorphic process. This has been divided into endogenic endogenic process and exogenic process. In the endogenic process, because here the force is being originated inside the earth only. Okay, so it has been divided into diastrophism and sudden. What is diastrophism? It is the deformation of earth crust. So the deformation of earth crust can be happened in two ways. Okay, the one is aperogenic. Aperogenic is what? This is the bending or uplifting of the earth crust that creates the continents, that build the continents. Some whatever the modification is happening in the continent, it is because of this aperogenic processes. If we talk about the mountain building and we talk about the foldings, this is orogenic. So orogenic is folding. This is the uplifting of the continents, and this come under the diastrophism, because diastrophism is what it is creating. It is deforming the earth crust. Okay, and deformation can be happen due to this as well. Okay, so and if we talk about the sudden, there is earthquake and volcano. We already know about the earthquake and volcano because we have discussed in the week 1 and week 2 session. And yes, in the volcanoes, there is the movement of magma, and this movement of magma can create intrusive as well as extrusive volcanoes, some different type of landforms within the earth or on the earth. Okay, so since geothermal gradient, heat flows, crust thickness and strength are uniform, because uh, we know that somewhere the crust thickness is less, somewhere the thickness is very high. Sometime the strength of the volcano is very high, somewhere the strength, because we already know that there are some specified reason only where there is a volcano, where there is a earthquake, so we have the specific location of that. So this is very uniform. The heat flow, the geothermal gradient, everything is very uniform. That's why these processes result into an uneven surface of the earth. So these were the endogenic. If we talk about the exogenic, then we have withering, we have the erosion, we have the mass movement, we have the transportation and deposition. We already have talked about this endogenic part in the week 2. So the next slide will be based on this exogenic part only. And what is this withering? What are different type of withering? What is the erosion? What are different erosion agents? And through that agent, what different type of landforms is being creating? Either it is erosional or it may be the depositional. Okay, so from now on we will talk about this exogenic only. So what are the driving force for exogenic geomorphic process? we have four processes in the exogenic. One is withering, the second is mass movement, the third is erosion, the fourth is transportation and deposition. So within the withering, the driving forces are gravity, the molecular stress, the chemical action, the biological action. If we talk about the gravity, then if there is some slope, if there is a gradient, then the withering will take place. So this is kind of gravity. Molecular stress, if there is a thermal expansion and the contraction, it will create the molecular stress, and because of that molecular stress, the withering will take place. So this is the molecular stress. If we talk about the chemical action, then some chemicals can react, and this can result into the precipitation, or this can also result into the dissolution of some material. For example, if we have calcium carbonate rocks, then because of the chemical action, because of the water that is running on the calcium carbonate rocks, and if we have acid in the water, then this will erode the calcium carbonate rock. So this is the chemical action. And the biological action, if some tree grows out from that rock, then it will make the mechanical stress within the rock, and it will also create some chemical produced by the roots, and these biological action will also result into the weathering. So these are the driving forces for the weathering process. If we talk about the mass movement, then only the gravity matters, not other things, neither the molecular stress nor this chemical action or this biological. Only the gravity matters here in the mass movement. If we talk about the erosion, then it is the kinetic energy. What is the kinetic energy? When some molecules are moving, then they have some energy. These molecules are bombarding with each other, and this creates the kinetic energy. So because of the movement, whatever the energy is created, it is the kinetic energy. So in the erosion, the driving force is kinetic energy. If we talk about the transportation and deposition, again kinetic energy will play an important role here. And the intensity of action of exogenic geomorphic process also depend upon the type of rocks, because if it is a soft rock, then the geomorphic process will happen very soon. Okay, if it is a hard rock, then a lot of much time will be needed for the degradation, or for the withering. Okay, so the intensity of action depend on the type of rocks, and their other aspects such as folds, the orientation and inclination of beds, the presence and absence of joints, the hardness of the material, the chemical reactivity, the permeability. Suppose if one rock is has a high chemical reactivity, then we can say that yes, the withering process, or the chemical action within the withering process will fasten the process of this geomorphic. Okay, so based on such aspect, the intensity of this process will be dependent. Because we will talk one by one about this withering, the mass movement, erosion, and transportation and deposition. So let's talk about what is weathering. So weathering is the mechanical disintegration and chemical decomposition of the rocks, and it is an in situ process. Why it is in situ process? Because it is happening on site. Okay. And there are three different types of weathering. The one is physical, the one is chemical, and third is biological. We already have talked about these three types. And withering is being regulated by geological factor, the climatic factor, the topographic factor, the vegetative factor, and the depth of the weathering mantle. So, for example, if we take the example of this topographic factor, so if we have a gradient that is if we have if we have gradient that is very steep, and if we have a gradient that is very much that is not that much steep, that is a shallow gradient. So if we have that steep gradient, then the weathering process will be very fast as comparison to that shallow one. If there is a vegetation, it may create the canopy. Okay, so so whenever a wind is coming out, or whenever like some other withering type of things are happening, these vegetation canopy can inhibit it. Okay, so there are different type of factor. The depth of weathering mantle. So uh, at what is the depth of that withering? So if we have a rock, so it may be happen that 5 centimeter of that rock has been withered, and if it is 5 centimeter, then it can shield it from further withering. Okay, if it is only 1 centimeter, then it may be that it can't shield from the further withering. Okay, so these kind of factor are also play a very important role in withering. So I think this is clear. Okay, let's talk about the physical withering. Uh, Here is the thermal stress. This is the thermal stress. If there is a sunlight and radiation is being falling on the rock in the daytime, but at the night time there is a no radiation. In the radiation, in the heat, this rock will expand. But at the night, when there is a no radiation, the rock surface will cool down and it will contract. So this is happening again and again. In the daytime it is expanding, at the night time it is being contracted. So what will happen? At the one time there will be the molecular stress and the outer layer of this will be broken. So this is kind of thermal stress. If we talk about the frost weathering or cryo fracturing, then what happen? If there is some crack within the rock, and in that crack we have a water, so in the winter time or in the night time, this water may get fridged. If it is fridging, then because we know that the density of the ice is low as compare uh, the density is low of ice as comparison to water, then it will expand. Okay, so whenever this is expanding, it is pushing the wall of this rock in the opposite direction. So this is happening again and again. It is converted into water, then it is converted into ice, and this is happening again and again. So what will happen? This will make the crack deeper, and at some time it will break down break down the rock. So this is the cryofracture, because of ice and water transformation from one phase to another phase. Okay, the third is mechanical action of oceanic wave. So what is the mechanical action of oceanic wave? This is the, like, when waves are pushing some landforms, it will erode it. Okay, it will wither it. So this is the mechanical action of the oceanic wave. The fourth is the pressure released due to the erosion of overlying surface. So if we have a rock, if we have a two rock, one is below and the another is above that below rock, at one time it may happen that the above rock can be eroded. So whatever the pressure the rock was getting from the above rock, it has been released, and because of this pressure release, the weathering can be take place. Okay, and the last is salt crystal growth. This may be happen just like this water and ice. If we have water, and in water we have some crystal, at some point it may be water get evaporated, and there is a and salt are being accumulating in this crack. Salt are being accumulated in cracks, then it will form a crystal. And because we know that mineral have the crystal characteristics, So if this crystal is being forming, then this crystal will push the walls of the rock, and that's why after some time the rock will break down. So this is the salt crystal growth. The second is chemical withering. So what is chemical withering? Because of chemicals, we only talk about some solutions and precipitate out in the chemical withering. So in the carbonation, the reaction of carbon dioxide or water with some chemicals of the rocks or the minerals, it may be that the chemical get precipitate out, and if it is being precipitated, then the withering is happening. So this is the carbonation. Hydration is if in some chemical we are adding the water, so within the chemical the formula gets like chemical dot H2O. So this is kind of hydration, and it will increase the volume, and if it is increase the volume, then the withering will take place. What is hydrolysis? This is the breakdown of water into H plus OH, and this also creates the chemical withering. The another is oxidation and reduction. So these are the chemical withering. The third type of withering is biological withering. We already have discussed. Here is the lichen. These lichens will secrete some chemicals. After secretion of some chemicals, these rocks will be exhausted and will be degraded soon. And here is the, like, if there is some seed inside this inside it, rock or in the crack, so a plant or a vegetation can grow, and this root again will create some chemical, and this stem will push this rock into two different directions. So this is the biological withering. So biological withering is the combination of both physical. Here we can see that this stem can push it in two different directions. So this is the physical, and the chemical is like if root is secreting the chemical, or if these lichens are releasing some acids, then this is the chemical. So so biological is the combination of both physical and chemical methods. Okay, so I think withering has been completed. Now we will talk about the mass movement, because we know already that this mass movement, the driving force is the gravity, no other forces but just the gravity. Please keep in mind. So in the mass movement, what happened? The movement of mass of rocks and debris down the slope by the action of gravity, not by the action of wind, water, ice, etc. So the movement of rocks, whatever the debris or the degraded rocks or the sand or the rock or the soil, everything will be down the slope by the action of gravity only. Okay, so withering is not a prerequisite, since gravity acts even on larger mass. If there is a withering, then mass movement will be faster, but this is not the it is not the prerequisite. Okay, and this mass movement will be favored if we have very weak and unconsolidated material, if we have vertical cliff and steep slopes, because in that steep slope the gravity will act very fast and within a short duration of time. Then if we have abundant precipitation or torrential rain, this will also help the gravity to the movement of debris down the slope. If we have scarcity of vegetation, because we know that roots of the vegetation hold the things together. So if we don't have the vegetation, and if we have removed the vegetation, that mass movement is being favored. If we have earthquake, then explosion, then vibration of machinery, these can also reduce the resistance of material, and so that mass movement can be happened. Okay, so there are three different type of mass movement. The first is heave, the second is flow, the third is slide. If we talk about heave is, let's take one example. If we have a layer of if we have layer of ice, okay, so let's say we have some crust, and because on that crust we have ice, in the this ice will expand and will change the structure of the crust. Okay, and if it is changing the structure of the crust, it may uplift the crust, and this may help to the mass movement. So this is heave. What is flow? Flow is when we have some liquid part. So if we have rocks and debris that are saturated with the water, so this will be flow. So this is a kind of flow. And it slide, what will be the slide? So if we have solid thing, and this solid thing will move as a single identity, okay, not like the flow. This will move as a single identity, then it is a slide. So there is a difference between flow, slide, and heave. We can also see some way of the mass movement. Fall, this is the free fall. Okay, so because of free fall, the things are just falling straight. Okay, if there is avalanche, in the avalanche the movement is this kind. If it is slide, then this is the single identity and it is sliding against a gradient. If it is a flow, then I told you that in the flow, this is like things will be saturated with the water, and with the water it will flow. If it's a slump, then some part of this will gradually will come down. And creep is just moving the debris or the rocks in a very like we can't see the creeping. It will move against in the gravity very slow. So this is the movement. Like creep and slump is a slow movement, but if we talk about flow, slide, avalanche, and force, this is the fast movement. So this is the direction of the fast movement, from slow to fast. So we have three classes of mass movement. The first is slow movement, the second is rapid movement, and rapid movement happens in the humid region when there is a when the debris or the rocks are being saturated by water, and there is a steep slope. Yeah, if there is such conditions, then a rapid movement will happen. The third is landslides. If we have dry environment, we don't have water and we don't have the saturated conditions here, so the slides will be happen. So either it is the debris slide or it is the rock slide, and not only the slide but fall will be happen, debris fall, rock fall, and the slump will be happen in the slide. So let's talk about this slow movement, creep and solidification. In the creep, what happens? This is very slow movement of rocks and soil debris. So if we have some gradient, in that gradient, very slow movement of soil and rock debris is happening. And how we can perceive that this is happening? So we can observe that the pole is tilted or the tree trunk is being curved. So in this way, we can observe that yes, this soil or the rock debris are moving in this direction, in this gravity. Okay, so in this way only we can perceive that creep. If we talk about the solifluction, then in that solifluction, this is also very slow movement of saturated soil and regolith. Here there was not saturated soil, but here is the saturated soil. So this is kind of like what we say it daldal. So here is the daldal, and this daldal will slowly go down with the gravity. So this is the Solé function. If we talk about the rapid movement, then there is the earth flow, mud flow, and avalanche. So here is the earth flow. Even here, the bedrocks may get slide down. Then here is the mud flow. When this mud flow happens, if there is a volcano, then this magma will create this mud flow, and it will flow very fast in a wide range, near to the volcano. If there is an avalanche, then this snow with debris and even the soil below this ice will move down along the slope with the gravity. So this is very fast movement. If we talk about the landslides, then slumping, then this debris slide and rockfall happens in the landslide, and there is no role of water here. So we talked about these three class of mass movement. So we already have talked about the mass movement. We talked about the withering. The third type was the erosion. And we know that here the driving force is kinetic energy. So, and there are some agents that are associated with the kinetic energy. What are these agents? Such like the running water, the groundwater, the oceanic waves. So these are the agents that have the kinetic energy, and these kinetic energy will move the debris or the soil down the slope or from one place to the another place. Okay, so these agents, the geomorphic agents such as running water and something like that, these has been divided into two parts. The first is that are being controlled by the climate, such as wind, the running water, and the glacier. And there are some agents that are not being controlled by the climate, such as waves and groundwater. In some way, in some different way, the waves can be controlled by the climate, but now we are just classifying it into very rough manner, so we can say that these are waves and groundwaters are not controlled by the climate. We also know the consequences of erosion. So we know that whenever the agent will lose the velocity or the kinetic energy will be low, this will create the deposition. Okay, and if the kinetic energy is high, the velocity of the agent is very high, this will erode the things. Okay, so the coarser material are deposited earlier than the finer material, because whenever the energy is being lost, then they will not have the capacity to carry the heavy material to the great distance. So they will leave that coarser material very soon, but they have that much energy, then they can carry some finer material to some distance. So that's why the coarser material are deposited earlier than finer material. Okay, and this will also aid the process of aggradation. Aggradation is the deposition, so this will have the deposition as well. Okay, so we have talked about the different type of processes in the exogenic, the withering, the mass movement, that erosion. So we already have talked about. So how this process can evolve the landforms. Okay, so if we have the Himalayas in the India or in the Nepal, so if erosion is being happening, the exogenic process is being happening, so it may be that this can create the floodplains. They may create some valleys. Okay, so how the landform evolves with the exogenic processes, so this kind of things will be studied ahead. So I think everything is cleared right now. Momita, everything is cleared?
Yes,
Or
ma'am.
or there is some doubt, then you can ask me, because this is the last part we will talk about. And yes, so we will talk about the evolution of landform that is being happening because of the exogenic processes. Okay, Chiranjeev, everything is cleared, or some doubt you have?
Yes, ma'am, no problem.
Okay, thank you. So whenever we are talking about the evolution of landforms, then the one of the important terminology is relief. So what is the relief? Relief is the difference between two elevation point on the surface of the earth. So for example, here is the sea level and it is a mountain. The elevation is no, this is not the sea level. Suppose it is 1200 feet from the sea level, and this point is 2700 feet from the sea level. So relief will be this minus this. So the value of the relief will be 1500 feet. Okay, so why this relief matter? Why this relief matters to us? Because if there is a high relief, then if there is a high relief, then we can say that the erosional capacity of running water or the agent will be high. Okay, because it is a steep kind of steep. And if we have low relief, then we can say that speed of the agents will be low, and this will have the this will form the depositional landform, not the erosional landform. Okay, so relief is important to us because it determines the speed of the agents. Okay, and what is the landform? Landform is a natural or artificial feature of the solid surface of the earth. For example, hills, for example, mountain or the valleys. So every landform has a beginning and a history shaped by the geomorphic processes and agents. So whenever a landform has been formed, so it will shape by some geomorphic processes and the agent. Because suppose we have Himalayas, so Himalayas will be not same after 1,000 years, because the geomorphic processes and agents will act upon it and will transform this land. Okay, so this is what has been written here. We already have talked about the geomorphic agents. So what are these geomorphic agents? These are the running water, the groundwater, the glaciers, waves and currents, and the winds. And these geomorphic agents can produce some features. These can be erosional or these can be the depositional. Okay, and the result of action of geomorphic agents are modified by the structure of landform, especially the hardness, folding, and faulting. I already have discussed about it, I think. We also have some independent control. What are these independent control? For example, the stability of sea level, because we know that if climate change is being happening, then the sea level is rising. If sea level is rising, then we can say that the relief, once the relief is high, after the sea level, high sea level, we can say that the relief has been not that much that was before, because relief has been reduced due to the high level of high sea level. So this is a kind of a thing where the shift of relief from high to low can be happening because of the sea level. So this is the independent control. The second is tectonic stability of the landmass. For example, if we have some crust, and because of tectonic activity, the crust has been moved down, or you can say the crust has been subsidized. If it is subsidizing, then we can say that once the relief was low, then this relief has been high, because because we have the subsidized crust. So the relief has been high because of this tectonic activity. So this is the independent control. And third is climate. We all know about the climate. So we will talk about this one by one, and how these agents, what type of erosional features they are creating, and what type of depositional features they are being created. We will see one by one. So if I talk about the running water, then the erosional landforms, it will create the V-shaped valley, the I-shaped valley, the stepped valley, the waterfall, plunge pool, river terrace, paired and unpaired. So this will be the erosional landforms that will be created by the running water. And please keep in mind, then when there is a high kinetic energy means the speed of the running water will be high enough. And if it is the high enough, then it will create the erosional landforms, because it have the energy that they can carry some material with it. And if it is carrying material from one place to another place, then it is creating some hollow, because it is carrying that material from that place. So this is kind of erosional landform. And if we are talking about the depositional, then here the kinetic energy is low, means the speed of water has been slowed down. So the running water doesn't have that much energy that it carry the debris or the rock forward. So it has to leave that material there only. And if it is leaving the material there only, it means there is a depositional landforms are being created. Okay, so the speed of the water will decide whether it will create the erosional landform or the depositional landform. Okay, so whenever these kind of valleys or waterfall or plunge pool is being forming, it is because of the high speed of the river water and the uh, carrying capacity of water to carry the rocks and debris. And so let's talk about it one by one. So here is the valley formation. So if there is a river, that river may cut the rocks, may cut the mountains from here. Okay, and it will the kinetic energy will cut this mountain or hills again and again. So it will form this V-shaped valley. Can you see that it is a V shape? Okay. So after that, it is because it is eroding the things. It is eroding the things by the time. So this will create the U-shaped valley. Okay, because it has been eroded in the below as well. Okay, so it will widens the valley. So at the starting it was I-shaped valley, then V-shaped valley, and then the U-shaped valley. And this is based on the speed of the river. If the speed of the river or the water is very high, it will create like it will go inside, go and make the cracks inside the mountains. And here will be like 90-degree angle cliffs or these walls. So this is the I shape. And when it will erode further, then it will create the V shaped and then the U shaped. If we talk about the rapids, waterfall, and plunge pool, so if here is a harder rock and here is the softer rock, so whenever the water is flowing from here to here, then because this is the soft rock, it will erode very quickly, and if it is erode very quickly, then it will create the waterfall. Okay, so this is the waterfall that is being happening by the running water. Okay, and because river, the water is not coming alone, it is carrying the debris, it is carrying the rocks with itself. So whenever the rocks will fall in this area again and again, this area will be eroded further, and the pool like structure will be created here. Okay, so and the movement of rock, because there the deposition of rock here, and then water is giving the kinetic energy, the rocks are just acting like the sandpaper that will erode this area further and will create the pool like condition. So this is the plunge pool. So this was rapid when there was a slope gradient. When this soft rock has been eroded, this rapid has been converted into the waterfall, because water is carrying some rocks, and water also have some kinetic energy. That kinetic energy is creating pressure on this area, and this will erode some further soft rock and will create a pool, that is the plunge pool. So these are the erosional features of the running water. If we talk about the depositional, then what will happen if this is a river that is meandering? Meandering means just like a snake moves now, so the river is moved just like that. It may be happen that at some time the course of the river get changed. So if the course of the river get changed, suppose it was moving once from here to here, but something happened that it changed its course here only. Okay, so it left that lake. This is the Oxbow Lake. This is the Oxbow Lake. And when there is no water in the lake, then this will create the scar. Okay. Then because river is moving, and we know that the speed of the water has been slowed down, so it will deposit the rocks, the debris on its sides. Okay, so if it is depositing the material on its side, so it will create the walls. These walls will known as the natural levees. Okay, it is just like the artificial river we have, like in the village. Whenever the agricultural water is needed, then there is an artificial river where we have walls. These in these walls the water moves. Okay, so but these are the artificial, but because of the slow speed of the water, the river create some walls in the lateral part. Okay, so these are the natural levees. Okay, so we already have talked about these natural levees. The another depositional landform due to running water is delta. So what happened in delta is, when the river is coming with the slow speed, and here is the ocean. Okay, and because it is coming with a slow speed, it will deposit some debris here. If it is depositing some debris, then the height of that debris will be high. Okay, so if it is like if the height of the accumulating debris is being high, then the channel have to move some other direction. Okay, so if there has been a collection of debris here, then this river have to move in the different direction. The river has to move in different direction. Okay, so so this river will create some tributaries. Okay, so this is going in this direction, this is going in this direction. Here is the ocean. So this is kind of triangle that is happening here. Okay, so this triangle is nothing but in the Greek, this triangle is known as the delta. Okay, so this is delta that is being formed due to the depositional capacity of the running water. And whenever whenever the river has a slow speed and have the debris and sediments, so it will deposit it in the lateral area, like here. So these deposition of sediments will create the floodplains. So here is the floodplains. So this, like, sediments are being depositing here. So this will create the floodplains, and these floodplains are more fertile region in our country as well, such as the region of Uttar Pradesh, Bihar, and some region of Haryana. So these are being created by the depositional river. Okay, so these are the rivers, and here only near the deltas where the river, the fresh water mix with the salt water, then here the estuaries form. Okay, so these are the depositional landforms due to the running water. The second geomorphic agent is groundwater. So because the erosional landforms will be the sinkholes, uvals, lapis, and caves. The depositional landforms will be stalactite, the stalagmite, and the pillars. Okay, and here note the kinetic energy, but the solution and precipitation will play very important role, and the rock compatibility, whether the rock is permeable, whether the composition of rock will play very important role in this type of landform creations. So let's take one example. So let's say there is a rock that is form of calcium carbonate. So because we have groundwater that has been once it was a part of rain, but that groundwater will react with the carbon dioxide and it will form some acidic form. Okay, and if there is acid and there is the carbonic acid, then no doubt that carbonic acid rock will be eaten up by that acid. So it will create some holes. So these holes are known as the sinkholes. Okay, and if this eaten up of the calcium carbonate is happening in the horizontal direction, so this is the horizontal direction, so this will create the caves. Okay, and this is also the sinkhole and whatever. So there was the sinkhole, then there was the uvalas. What are the uvalas? If there is a chain of that sinkhole, so whenever the chain of sinkhole is being formed, then this because this will not will remain as the sinkhole, we will call it as the uvalas. And if we have some like image of the sinkholes in different directions, then these are the lattice. We already have talked about these caves. And if we talk about the depositional, then see here, when the sinkholes are in the horizontal direction, that it has been created the caves. This is the erosional. But because whenever this calcium carbonate is being mixed with the water, and it may be that these may precipitate out in this direction. Like you can see that the dissolution or the precipitate out of this calcium carbonate can form this kind of structure as well. So this is stalactite. Okay, and if if this type of accumulation of calcium carbonate is being happening from below to high, this is stegmite. And when this stalactite and stalagmite is is adding and is forming a one structure, then we call it as a pillar. So we can see here it is a pillar. These are the stalactite and these are the stalagmites. So these are forming such kind of structure within the caves. So these are the depositional, but cave itself is the erosional landform. Okay, so we have talked about the running water, we have talked about the groundwater. So the next is the glaciers. Okay, so in the erosional landform, it will create the cirques, the arities, the horns, and the hanging valleys. In the depositional, it will create the glacial tilts. These tilts will, when these tilts create the ridges, the steep ridges, we call it the moraines. And then outwash deposit, eskers, and drownings. So if you don't remember like what the cirque is, what the horn is, but you must know the name of the landforms, and either these landforms are erosional or the depositional, because these are the questions that are being asked in the UPSC exam as well. So if they give some type of landform, and they will give you the question which one is the erosional landform that is being created by the glacier only. So you must know the names of each landforms by the different geomorphic agents. Okay, so if we talk about this geomorphic agent glacier and the erosional landforms that are being created by the glacier, so we have that cirques. These cirques are nothing but when the glacier moves. So these the debris, the sediments are moving along with the glacier, and this will create such kind of structure. So these are the cirques. Okay, and if we have two cirques, let's say yes, if there are two cirques, one is here, the another is here. So these are creating a ridge that is very steep. Can you see that ridge? So this is the ridge when these two cirques meets to each other. So this ridge is nothing but the arity. Okay, and if there are more than three cirques, for example this 1 2 3, so here can you see that there is again a steep ridge is happening here, is forming here. So this is horn. So first you will start with the cirque. There is a cirque that is like the erosional capacity of the glacier is creating the structure. If two cirques are meeting each other, so here is the ridge that will be formed. So this ridge is the arity. If there is more than three cirques, so there are more than three, 1 2 3 4, so here the ridge is formed. This is very steep and this is known as the horn. Okay, and after these after the glacier movement, there may be like this is the valley that had the very dead end, like there is no slope here. This is, there will be free fall. Okay, so that's why this valley is the hanging valley. So the this has been clear, this has been cleared: the cirque, the arities, the horn, the hanging valleys. If we talk about the depositional landform, so we can see here that the erosion has been taken place. There is a, you can see a shallow areas. Okay, but in the depositional, what happened? Because this glacier also have to deposit the debris at the some place now. So if it is carrying the debris from this place, it has to deposit somewhere here or somewhere, like whatever the material, because here the material has been gone, so it will be deposited somewhere else. So if it is depositing in after the glacier, at the end of the glacier, then it will be known as the terminal moraines. And this terminal moraine is being named after the till, this till, after, like whenever the deposition is being taking place, the deposition will create the ridge like structure, a sharp ridge it will create. The deposition will create the sharp ridge. And when there is a sharp ridge is creating, then this sharp ridge is known as the moraines. So see, here is a ridge being created. So this ridge is known as the terminal moraine. It may be that this ridge is here only. Okay, so this is the lateral ridge. Okay, so these are the lateral moraine. Sorry, so the if it is a side of the glacier, then it is the lateral. If it is the end of the glacier, then it will create the terminal moraine. Okay, and it happens that whenever the glacier is moving, so below it there may be some river that is also moving. Okay, so whenever the deposition of the debris is happening because of that river, okay, so that will create the escarts. Okay, and when this moraine, just like a moraine, a ridge is happening, but this is very rounded and smooth ridges when forming due to the glacier deposition, then we call it the drumlin. And again, just like the running water, the floodplain is formed. So there also floodplain are formed. So these are the depositional landforms of the glaciers. I think we have 2 or 3 slides more. Then we will discuss something else. So the next is geomorphic agent, waves and currents. So if there are waves and currents, then this wave and currents will erode the whatever the land feature we have. So this can create the cliff, the wave cut terrace, the sea caves or the sea stacks. And in the depositional, it will create the beaches, it will create the offshore sandbars, and it will create the spits. So here is the example. If the waves, if this was once again the crust, the continental crust, and waves are coming, waves are pushing this, the mechanical action of the waves are just pushing this landform. So what will it create? It can like erode some areas, and it can create this pillar like structure. So this is called the stack. It may be happen that some of the soft material are being eroded, so there may be some hard material here, or it may be that the direction of the waves is only giving the pressure in this direction only, so it will create like hollow inside, but there is a layer of landform above it. So this is the arc like structure. Okay, there may be they may create some cave like structure as well. uh, you also saw that there is some island as well. In that island, what happens, like these wave cut platforms, just like some plateau or island kind of landforms are also being created. So these are the wave cut platform, and if the size of that stack is low, then we called it at a stump. And these are the cliffs. Whenever the ocean is pushing this heel or the rocks, then it will create some straight, the 90-degree or the 80 to 90-degree angled these features. So these are the cliffs. So this is also the example of stack, and this is the wave cut platform. So these are the erosional features that are being created by waves and oceans. So what are the depositional? So in the depositional, we know that beaches. Okay, so in the beach, what happens whenever the wave it come with the sediments, and it spread the sediment hairs. Okay, so whenever the it spread the sediment hair, it leave the sediment hair, so the beach is created. Okay, it may be happen that the sediments that are moving with the waves can create such kind of structure. So this is the sand spit. Okay, and it may be happen that it is creating some island kind of sandbars. So this is offshore, because this is not near to the beaches, not near to the shore, but it has been created separately. So these are the offshore sandbars, and these are the sand dunes. We will talk about sand dunes in the wind geomorphic agents. So this is the depositional landform. So you have to remind the names. In the erosional, it is cliff, it is wave cut terrace, then the sea caves and the sea stacks. In the depositional, we have beaches, we have offshore sand bars, and we have spits. If we talk about the winds, then the erosional landforms are pediments, the pediplains, the playas, the deflation hollows and caves, the mushroom-like structures, and in deposition, we have sand dunes. Okay, so let's see. If here is the mountain and the wind is coming from this direction, then the sand, the eroded part will spread here. Okay, so debris will start accumulating here. So this is the like the rock floor that is formed due to winds are known as pediment. Okay, and these winds will further spread this rock floor or the sand away, and this will create the pediplains. Okay, so this is the example of pediplains. And in the depositional, we talked about the dunes. So what happens in the dunes? Whenever there is a wind moving in some direction, it will move the sand from one place and deposit it or accumulate it at a different place. Okay, so it is moving the one landform, like one dunes at a one place to different place. Okay, and and it may be that the winds are moving from different direction. So the structure of dunes can be very different. Okay, so this is the depositional. So I think it has been like cleared from my side. If there is any doubt, you can ask me. If everything is clear, then it is okay. Then if it is not, then you can ask me the question. Khushbu, everything is clear?
Yes, ma'am.
Okay. Chiranjeev,
Yes, ma'am, everything is clear. Ma'am, can we get the
uh,
PDF of this topic?
can you get the
Can we get the PDF of this topic? PDF.
PDF?
Yes,
Yeah,
ma'am.
I can give the PDF, but whatever the slide I created, this slide is also accessible to you. So you can also download this slide and can see it, because a link of the link of the Google Drive will be shared with you. So have that Google Drive link been shared with you?
Not yet, ma'am.
No, ma'am.
Okay.
No.
I think that link of that slide and even the video has been given below that course description. I think you can see it, and if you can see it, let me know, because I saw it that there is a link provided in the course itself. So please tell me when it is not available to you. Okay. Bindu ma'am, was I clear to explain the things or not? Should I improve something?
No, ma'am, it was clear. All the contents were included. Thanks, ma'am.
Oh, thank you. Thank you so much, ma'am. So let me summarize it. So we started with the lithosphere. Okay. In the lithosphere, we talked about, because lithosphere is composed of rocks. So we talked about rocks because rocks are composed of minerals. So we talked about different type of minerals, and after that, these minerals, we talked about minerals. Then after that, we talked about different type of rocks we have, from igneous to sedimentary to the metamorphic rock. We talked about the rock cycle, how these rocks can be converted from one type to different type. Then we talked about the earth landforms, so how the landforms are being created, what are the processes, what are the forces that making our earth very uneven, and how these landforms are being evolved. Like once it was if, for example, if there was a Aravali hills, so now it has been eroded. Once upon a time it was very steep, but with the time it has been eroded and it has become from mountain to hill, or like a plateau, like plateau type of thing. So how the landforms has been evolved, what are the processes, so we talked about it. Especially we talked about the exogenic processes, how the weathering, how the erosion, how the mass movement, and how the transportation and deposition is acting and evolving our landforms. And in the erosion itself, we had the geomorphic agents. That geomorphic agents not only create the erosional landform but the depositional landform. So for the each geomorphic agents, we discussed the different type of features that are being created, the erosional and the depositional one. We also tried to know, like, what's the difference between the different features. So if it is a V-shaped valley, or if it is a U-shaped valley, or if it is a like plunge pool, so what is the difference between these type of features? Because these all features are the erosionals, and all these features are being created by the running water only. So what are the difference between these? We also tried to cover. Then from this running water to groundwater to oceanic waves to winds, we try to cover all the geomorphic agents and how these agents are making our land very even. Some forces are creating the undulating structure of the earth, and some forces, some processes are making the earth plain. But this is very heterogeneous. Okay, somewhere the erosional landform is being created, somewhere the depositional. So the processes are trying to make the earth very plain. Okay, so they are trying to make the earth even, but our different forces, and because of like our different kind of crust, we have different type of like features of the earth we have. So the earth is being very even after the two different forces like exogenic and endogenic. We have the uneven uneven structure. So exogenic is always trying to make a earth planar. Okay, but we have the endogenic. Within the earth, we there are some forces that are creating the continents, that are creating the mountains because of faults, because of foldings, and these are making the earth undulating. Okay, so these are the two different type of forces you have to keep in mind that are creating our earth very beautiful. Because if it will be the plain area everywhere, you will not enjoy that much that you are enjoying the hills. Whenever you go to Manali or whenever you are going to Leh Ladakh, you just like the hills. Okay, when some people from the hilly area come to the area like UP or the Haryana, they see the flood plains and they see the like crop everywhere in the plain area, so they enjoy it. So these uneven structure of the earth is given by our two processes, the exogenic and endogenic. So this is the crux, and we are very blessed that we have such processes that is happening automatically, like we don't have to do anything. And if yes, if people are doing if people are interfering it, then something bad can be happened. Okay, so we are fortunate that we have this kind of mechanism, this kind of force within the earth itself, and that's are creating our earth very beautiful. So I end this live session here only. If you people have some doubt, you can ask. Otherwise, we will end this live session here only, because our live session is only from 6 to 8. So every Sunday we will talk, we will discuss. Whenever you have doubt, you can come with me. And yes, my knowledge will also upgrade because you people are from geography. So whenever I do some mistake, you can correct me, you can upgrade my knowledge. So thank you, everyone. If you have any doubt, you can tell me. I will try to clear it in the next session or within this session. Otherwise, you can leave this Google Meet.
Okay, ma'am. Thank you, ma'am.
Thank you,
And
ma'am.
thank you, Chiranjeev. Thank you, Khushbu.